As a new aircraft capable of vertical takeoff, like a helicopter yet capable of high speed, cruising like a fixed-wing plane cuts through the skies between sea and sky over the Western Pacific, has the world realized that a profound aviation revolution is quietly unfolding. Recently, a series of test flight photos of a domestically produced tiltrotor aircraft caused a stir online. Its distinctive appearance was immediately recognized by keen military enthusiasts as bearing a striking resemblance to the U.S. military's next-generation flagship model, the V-280 Valor. This is more than just the unveiling of new equipment. It feels like a crucial piece precisely fitting into the Chinese Navy's blue water strategy, signaling a potential reshaping of amphibious assault and carrier-based warfare models. Even more intriguing is the serendipitous overlap in timing between its maiden flight and the ongoing sea trials of the Chinese Navy's Type 076 amphibious assault ship, the Hainan. This coincidence leaves endless room for speculation. Are we witnessing the dawn of an era where aircraft arrive on carriers fully operational? Delving into the aircraft's design reveals its ingenuity. It stands on the shoulders of giants, while sidestepping their pitfalls. Unlike the early U.S. V-22 Osprey's complex design, which tilted entire engine nacelles, China's new model adopts a second-generation approach similar to the V-280. The engines remain firmly fixed to the wings, with only the top rotors and transmission mechanisms tilting. This split-rotor tiltrotor design represents an exceptionally precise technical choice. The V-22's integrated tiltrotor structure came at a heavy cost: mechanical complexity, frequent accidents, high-temperature exhaust streams scorching ship decks, and reduced door clearance increasing parachute evacuation risks. China's solution bypassed these historical pitfalls, significantly simplifying the structure, reducing failure risks, and fundamentally enhancing safety. As one expert wryly noted, it's like picking fruit from the shoulders of those who failed, reaping safer, more reliable technological rewards through the most direct means. The advantages of this design extend far beyond safety. Hidden within the wings lies a critical safety redundancy, a drive shaft running through both sides. This means that even in the extreme scenario of one engine failure, the remaining healthy engine can still drive both rotors via this shaft, maintaining basic lift and balance. This prevents loss of control and rollover caused by unilateral power loss. Additionally, its T-tail design, commonly seen in large transport aircraft, is widely recognized for providing superior flight stability. These details reveal that from the project's inception, Chinese engineers have embedded safety and reliability into the aircraft's very DNA. So, beyond its ingenious design, how does it perform in practice? While official specifications remain undisclosed, aggregated intelligence paints a remarkably impressive performance profile. Reports indicate a potential cruising speed of 550 km per hour, nearly double that of conventional transport helicopters currently in service. Even more astonishing is its range, with a maximum range potentially exceeding 4,000 kilometers and a mission radius capable of covering 1,500 kilometers. To grasp the significance of this leap, consider this vivid example: traveling from Hainan Island to the distant James Shoal in the South China Sea. Conventional helicopters, constrained by range limitations, often require complex mid-flight refueling arrangements. This tiltrotor aircraft, however, can effortlessly complete the round trip thanks to its extraordinary range. This capability will fundamentally transform patrol, resupply, and emergency response operations across vast maritime regions like the South China Sea. It is precisely this exceptional combination of speed and range that renders its military applications, particularly when integrated with new naval vessels, truly disruptive. Currently, the Chinese Navy operates multiple Type 075 amphibious assault ships, while the lead ship of the Type 076 class, dubbed the mini aircraft carrier, has commenced sea trials. One of the most striking features of this warship is its electromagnetic catapult system and ample deck space, widely regarded as an ideal platform for drones and various new concept aircraft. Imagine the synergy if this tiltrotor aircraft were deployed on the Type 076. The vessel could remain safely beyond enemy shore-based fire range, while the tiltrotor aircraft would deliver assault troops or special operations teams at speeds exceeding 500 km per hour, like lightning, to target areas hundreds or even thousands of kilometers away, achieving a truly over-the-horizon vertical landing. This capability represents a tactical leap far beyond what existing helicopters can offer. Beyond its role as an assault transport, its modular design endows it with versatile capabilities. Large cargo doors on the fuselage sides and rapid access to the cockpit indicate consideration for roll-on, roll-off equipment and rapid personnel egress. With a payload capacity of approximately 2 tons, It can transport troops and ammunition while flexibly reconfiguring into anti-submarine patrol, reconnaissance and early warning, or even electronic warfare variants as mission requirements dictate. More practically, it should feature folding wings, freeing up valuable space on crowded ship decks for other aircraft, and significantly enhancing the operational efficiency of carrier air wings. However, the path to carrier decks is not entirely smooth. Several challenges must be addressed for its full integration into naval systems. First, fixed-wing fighters and early warning aircraft will remain the absolute core and combat backbone of carrier strike groups for the foreseeable future. The tiltrotor's role is more likely to shine in auxiliary and support missions, such as gradually replacing existing Z-8 or Z-20 helicopters to undertake critical duties like rapid vertical resupply, long-range search and rescue, anti-submarine patrol, and long-range special operations deployment. Second, the maturity of the technology, particularly the lifespan, reliability, and stability of domestically produced engines, the aircraft's heart, under extreme maritime conditions of high temperatures, high salinity, and high humidity, still requires extensive validation and refinement through prolonged, high-intensity flight testing. The maturation of any new aircraft inevitably demands such a rigorous, even demanding, process. Fortunately, China did not start from scratch in this field, but pursued a phased development strategy, prioritizing unmanned systems before advancing to manned variants. Before the manned tiltrotor aircraft took flight, China had already built substantial technical expertise in unmanned systems. For instance, the previously unveiled CH-10 unmanned tiltrotor aircraft successfully overcame the globally challenging issue of stability control during flight mode transitions, validating critical technologies. Another highly anticipated model, the Liaoning 6000 unmanned tiltrotor, boasts even more impressive design specifications, a maximum range of 4,000 kilometers, a payload capacity of 2 tons, and the ability to land stably even in Category 10 typhoons. These achievements have paved the way for manned aircraft development. Looking beyond the military sphere, this aircraft represents a vast new frontier in civilian and national economic applications. In plateau regions, it provides stable, reliable supply lines for border outposts. On remote islands, it establishes efficient lifelines during disaster relief operations. Its speed advantage allows it to reach the epicenter faster than traditional helicopters. It is also one of the core engines driving China's low-altitude economy. In the future, it will demonstrate irreplaceable value in high-end business travel, emergency medical transport, and efficient logistics distribution. From the perspective of military-civilian integration, the demands and technical feedback from the civilian market will also contribute to the continuous improvement and cost control of its military variants. Globally, tiltrotor aircraft have become a focal point of competition among major powers. America's V-280 Valor has been selected as its next-generation flagship model, while Europe's A609 is undergoing active carrier testing. The successful maiden flight of China's first manned tiltrotor marks not only our entry into this elite club, but also our choice of a more stable and secure technological path. When it sails alongside China's future carrier strike groups in the Western Pacific, it will represent more than just a new piece of equipment. It will embody a multidimensional combat concept integrating high speed, long range, and vertical takeoff and landing. While it may not replace fighter jets as the dominant force in maritime airspace, it will undoubtedly become a critical node connecting ships to distant targets and underpinning the entire strike group's operational network.